Welcome back to Applied Mathematics. This video is an introduction to factoring. Depending on your mathematical background coming into this course, factoring might be something you are very familiar with. It might be something that you vaguely remember from a previous course, or it might be something that you have never really studied closely in the past. I'm going to try to make this accessible for anyone in any position while still giving us some interest for those of you who do have some background on the subject. That being said, factoring is one of the most challenging topics to teach in the applied mathematics course or sequence because the applications are not very obvious. In most of the videos in this course or this course sequence, if you've been with me through 2 courses, I try to show you skills and directly show you how those skills relate to solving everyday problems or solving problems in particular fields. Factoring is challenging in that regard because you really need to have a strong understanding of how factoring works before you can get to solving the problems. All that is a long way to go for me to say that I'm going to go through an example out of physics, out of kinematics specifically, that I don't necessarily expect that you can follow along on. You should be able to follow along as far as understanding and accepting that everything I do makes mathematical sense. I'll write down an equation. We won't worry too much about where the equation comes from. And every step, I think you'll be able to agree, is mathematically equivalent, although it's not going to be clear yet how I got those steps if factoring is not something that you're already familiar with. All right. So, in kinematics, one of the most powerful formulas that we work with says that d is equal to v naught t plus 1/2 a t squared. In this formula, d is the distance that an object falls, v naught is the speed that the object is falling initially, t is the amount of time that the object falls, and a is the acceleration that the object is undergoing. So I'm going to look at a particular example of an object that has to fall 384 feet. It is initially falling, when we first notice it, at 80 feet per second. And the acceleration due to gravity in the US customary system is 32 feet per square second. Half of that is 16. Right, this is not a physics course, so don't worry about where those numbers came from, how I understand them, but I wanted to give you that context of here is where these things might show up in an equation. In order to solve this equation, we are going to first rearrange the equation by getting everything on one side. The next thing I'm going to do is divide through by 16. Divide through by negative 16. Negative 16 divided by negative 16 is 1, so that first term is just t squared. Negative 80 divided by negative 16 is positive 5. And positive 384 divided by negative 16 is negative 24. Yes, these numbers work out magically because they are a prepared example. Right? Those 2 steps are just following the rules of manipulating equations that you've used many times in the past. It may not be obvious why I want it in this form, but you should be able to follow that it gets into that form. The next step is the step where I factor. And I'm just going to cut to the chase and tell you that this is going to factor into t plus 8 times t minus 3. If you have no idea where that line came from, you are in the right place. I don't expect you to understand how I got that line. I'm going to spend the next several videos trying to convince you that you will be able to figure that out. Instead, for right now, I want you to focus on making sure that you can go backwards. If you multiply out t plus 8 times t minus 3, verify for yourself that you would end up with t squared plus 5t minus 24. So I haven't done anything to change the expression. I've just turned it from what is going to have been an inconvenient form into a somewhat more convenient form. The next step is also black magic, but it's black magic that I can explain without that much difficulty. It's called the zero product rule. The zero product rule says that if you have a couple of things being multiplied together and the result is 0, then one of the things you are multiplying must have been 0 in the first place. The only way you can multiply things together and get 0 is to multiply 0 times something. And so by the zero product rule, it must be the case that either t plus 8 is equal to 0 or t minus 3 is equal to 0. These are both relatively simple equations to solve. If t plus 8 is equal to 0, that means that t is equal to negative 8. Well, that makes no sense. That would mean that our object has fallen for negative 8 seconds. In application terms, we very often end up with an extraneous solution. It's not always the case that the negative solution is extraneous, but in kinematics, that's a common thing to have happen. The other solution says that t equals 3. The object has fallen for 3 seconds. And that makes a lot more sense. So when you have an application, thinking about the fact that you have two solutions, and some of them may make more sense than others, is important. But whether or not you can eliminate a solution is very much dependent on the application. For the most part, I'm going to stick with abstract examples. I want to focus on the mechanics of how to work with this factoring and how to work with this zero product rule. So we're not going to worry about eliminating extraneous solutions or anything like that. We're going to make sure that we understand the foundations so that we can move onward to places that build off of this basic skill. So when it comes to factoring, the first and easiest rule is called the greatest common factor rule. If I have an expression, I can look for factors in each term of that expression, and I can remove those factors using the distributive property kind of backwards. So if I have something like 12x plus 21, I notice immediately that I've got unlike terms I can't simplify. I don't know what x is. Only one of the terms has a variable at all. But then if I look at the constants, 12 and 21, 12 and 21 are both divisible by 3. 12 is 3 times 4, and 21 is 3 times 7. Now that I see that common factor of 3 in both of the terms, I can factor it out. And factoring out looks like the distributive property working backwards. If I gave you that last line, 3 times the quantity 4x plus 7, and asked you to simplify, then you would multiply 3 times 4x plus 3 times 7. You would write directly this line. Maybe you wouldn't write it out, but you'd at least think it. and then you would do the multiplication to get back to this line. The process of factoring is working directly opposite to the process of simplifying that we have used in the past. Greatest common factor will work when you have constants that have common factors. It will also work very nicely for common variable factors. If I have 4x squared minus 15x cubed, each of these terms has at least one factor of x in it. In fact, they both have at least two factors of x. I could rewrite this as x squared times 4 minus x squared times 15x. And now that I see that, I can factor out the x squared, which will leave behind 4 minus 15x. Again, it looks exactly backwards to how you would simplify using the distributive property, and that's by design. It's just the distributive property working backwards. There's not a whole lot that I can do with this greatest common factors approach on its own, but it is a powerful building block for other techniques. Before I get much further, I do want to mention that just like using the distributive property, when you first learned it, you learned to write out that intermediate step before simplifying, but after you got comfortable with it, you learned to just jump straight from the beginning to the end. The same thing with factoring. If you are not familiar with factoring, I strongly encourage you to write that middle line out on your way, but once you are comfortable and you know what you're doing, jumping from the first line straight to the last line without doing that middle step is perfectly fine. It's perfectly reasonable. And that's honestly how I usually write things out. Even just with this rule of factoring out a common factor, you can use it to solve equations. If you have an equation that says x squared minus 5x is equal to 0. Well, there's a common factor of x in each of these terms. You have x times x, and you have x times minus 5. So we can factor it and rewrite it as x times x minus 5. Now, because the right-hand side of the equation is 0, I can use the zero product rule. Which gives me that either x is equal to 0 or x minus 5 is equal to 0. And if x minus 5 is equal to 0, x itself is equal to 5. I get two solutions this time, x equals 0, x equals 5. I don't know enough about the scenario to say whether one of these is an extraneous solution or not, so I'll just keep both of them for now. The next tool in our tool chest is called factoring by grouping. And factoring by grouping requires a not prime number of terms. Remember, the prime numbers are numbers who can only be written as the product of themselves and 1. A non-prime number can be written as a factor of other things. Well, 1 is boring because having one term you don't want to factor anything. 2 is a prime number, so that's out. 3 is a prime number, so that's out. 4 works. 5 is a prime number, so that's out. 6 works. 7 is a prime number, so that's out. 8 works. And you could keep going. 9 works as well. But I'll be honest, if you have 4 terms, you're going to do this. If you have 6 terms, you might try this. If you have 8 or 9 terms, you're going to give up and make the computer do it for you. So let's consider something like x cubed minus 7x squared plus 5x minus 35. In order to factor by grouping, we are going to do what the name suggests. We are going to group. You can have as many groups as you would like, but you are required that every group has the exact same number of terms. In this case, I have 2 groups with 2 terms each. Now I'm going to focus on just that group. In x cubed minus 7x squared, I can factor out a greatest common factor, in this case x squared, and when I do, it leaves behind x minus 7. In my second group, I can factor out a common factor of 5, and when I do, it leaves behind x minus 7. That's weird. I got the same x minus 7 in both of those places. That almost never happens. But it has to happen in order for factoring by grouping to work. We will learn a little bit later how to take an expression that does not have 3 terms, an expression that does not have 4 terms, rewrite it as an expression that does have 4 terms, and then have these terms work out so that factoring by grouping will work. It's not as contrived as it seems at first glance, but it is somewhat contrived. You needed these specific terms for this process to work. I have to be very careful in examples that I give you. All right, but now that we have this, I want to go off to the side for a second and just think about what we're doing. I have x squared times something plus 5 times the same something. I can factor that using the greatest common factor. That extra thing I've written as a gets factored out, leaving behind x squared plus 5. It looks really strange to do when that thing we are factoring out is the binomial x minus 7, but it still works. X minus 7 times x squared plus 5. If you multiply this out using the distributive property, using FOIL, however you like to call it, you will get x cubed minus 7x squared plus 5x minus 35. We haven't changed anything. And in fact, I strongly encourage you to double check that. Make sure that it's going to work. Before I wrap up this video, I want to go through one more example like that, because one thing that you do have to be careful about is the signs, S-I-G-N. Sometimes weird things can happen. So let's take a look at 3x cubed minus 12x squared minus 7x plus 28. If I group this, well, my first 2 terms are going to be 3x cubed minus 12x squared, and then I'll have plus, and that's a little bit weird because in here I'm going to have a negative 7x plus 28. In my first group, there is a common factor of 3x squared. It leaves behind x minus 4. In my second group, there is a common factor of 7. It leaves behind negative x plus 4. That's almost the same thing as x minus 4, but not quite. Specifically, it's different by a negative sign. Right? If I multiplied negative x plus 4, and I multiplied through distributing negative 1, I would get x minus 4. And, well, I can't quite just do that, but I can take that to heart and say that, no, this line was not what I wanted to do. I should not have factored out a 7. I should have factored out a negative 7. If I factor out a negative 7, well, negative 7 times x is negative 7x. And negative 7 times negative 4 is positive 28. Something to pay attention to: when you break out your two groups, you will very often end up in a situation like this, where one of the groups has a positive leading term and the other group has a negative leading term. Factor out the negative in your grouping that has the negative leading term. Then those binomials that are left behind, x minus 4 in this case, are the same thing. That gets factored out, and it leaves behind 3x squared plus negative 7, which we would probably just write as 3x squared minus 7. We still have a ways to go. There are a number of techniques that are necessary before we are finished with the idea of factoring. You might notice right away that I can no longer use my zero product rule. Or if I tried, I would get x minus 4 equals 0, which is fine. Then I'd get 3x squared minus 7 equals 0, which is a little bit less fine. So there's more to come. We will get to solving some practical problems by the time we're done with this, but for right now, I'm just going to leave it at these two skills. Make sure you're comfortable with those, and I'll see you in the next video.